Welcome to this explainer. Today we are tackling something absolutely massive. We're going to take the incredibly complex world of modern IT architecture and break it entirely down into its foundational building blocks. By the time we're done here, you're going to see exactly how the digital world really operates, starting from the physical hardware sitting right there on your desk, all the way up to the invisible legal frameworks that govern global data. It's like a giant puzzle, and we're putting the pieces together. Here's our roadmap for the journey. We're moving straight from the micro to the macro. We'll kick things off with core systems and software, expand outward to networking and cyber threats, push all of that up into the cloud, give it a brain with information systems and AI, and finally, lock the whole thing down with cyber law. Okay, let's dive into this with Section 1, Core Systems and Software. So what actually makes a computer a computer? At its strict foundational core, a computer system relies on a continuous, unbreakable loop. It accepts, processes, stores, and outputs data. I know, it sounds super basic, but this exact flow governs literally every digital interaction you have. You feed it raw info, the processor and memory go to work handling it, it stores whatever is needed, and then bam, it gives you a tangible output. Now, if you want to evaluate any system strategically, let me give you a little cheat code. It's called the HSDPP framework. A system is never just a machine. For it to work, you absolutely need hardware, software, data, procedures, and people. It's not just physical parts and lines of code. Without the raw data flowing in, the operating procedures telling it what to do, and the actual people to run it, the entire system just falls flat.
And think about the software running all of this. There's a really interesting contrast here between the roles your software plays. System software, things like Windows or Linux, is basically the boss. It manages the hardware, allocates memory, schedules the CPU, and generally just keeps the lights on. Application software, on the other hand, like Microsoft Word or a hospital management system, sits on top of that foundation. Its only job is to help you perform specific daily tasks.
So we've got our standalone machine, right? It's perfectly running its software, processing its data, but an isolated computer is honestly pretty limited. The real power is unlocked when we ask, how do we connect these standalone machines to the rest of the world? Which brings us right into Section 2, networking and cyber threats. When we start linking devices and scaling networks, access is everything. An easy way to remember this is inside, extended, and everyone. Think of an intranet for inside only, a totally private network, like a company's internal HR portal. Then you have an extranet for trusted outsiders. That's semi-private, maybe allowing a specific supplier to access an order system. And finally, the internet. That's for everyone. It's public, it's open, and nobody entirely owns it. We can also classify these networks by their physical range and speed. A LAN, or local area network, covers just one building or campus, and because it's so contained, it offers the highest speeds. Step that up to a MAN, and you're covering an entire city. Then there's the WAN, or wide area network, which is totally global. Now, as physical range increases, your relative speed generally decreases. This is exactly why global WANs have to rely on massive subsea fiber optic cables spanning the actual ocean floor, literally just to keep our internet from lagging. Of course, rapid network growth forces constant innovation. Every single connected device needs an IP address. We started out with IPv4, which used a 32-bit format. That gave us about 4.3 billion addresses. Sounds like a lot, right? But with smartphones, smart TVs, and even smart thermostats flooding the market, we actually ran out. The internet literally had to evolve to IPv6, a 128-bit format that gives us a practically unlimited, mathematically staggering number of addresses to handle all our gadgets. But connecting to the world invites a massive, massive array of threats. We use the mnemonic VMSSPRDH to remember the big ones. The digital world requires constant vigilance against data corruptors like a self-replicating virus or malware. You've got deceptive attacks like spoofing and phishing, and downright extortion like ransomware, where your files are literally locked down until you pay up. Then there are denial-of-service attacks that flood servers until they just crash, and of course, outright hacking. Okay, so we've built the network pipes, and we've locked the doors with our security measures, but with all this massive global data constantly flowing back and forth, it raises the next crucial question. Where are we actually storing all this stuff? Let's figure that out in Section 3, the cloud and computing models.
You hear the term all the time, but cloud computing is simply the delivery of computing resources over the internet on a pay-as-you-go basis. That is the strategic magic of it right there. Instead of buying, maintaining, and owning a bunch of physical hardware, you're just renting infrastructure, servers, storage, and software on demand. It gives organizations absolutely massive cost savings and, most importantly, immediate scalability.
Now, the way you rent these resources generally falls into 3 tiers, and a good memory trigger here is IPS. You can rent bare metal virtual hardware with infrastructure as a service, or IaaS. Think renting raw AWS servers. You can rent developer environments with platform as a service, or PaaS. Or you can rent ready-to-use applications with software as a service, SaaS. With SaaS, everything is hosted and ready to go. It's like when you just log into your Gmail or Zoom account. Moving right along, let's hit Section 4, Information Systems and AI.
You can think of an organization's information system building logically, kind of like a giant pyramid. At the very bottom, routine TPS transactions, like an ATM withdrawal, feed raw data up into the MIS to generate middle management reports. Above that is the DSS, analyzing complex what-if scenarios for major executive decisions. And sitting at the very peak is the KMS, transforming all that day-to-day operational data into high-level strategic corporate knowledge that gets shared across the entire enterprise. And today, we are basically turbocharging that entire pyramid with artificial intelligence and machine learning. What's absolutely amazing about this is that machine learning models discover hidden patterns on their own without explicit programming. This is a real game changer. It allows them to automatically detect a fraudulent credit card swipe in milliseconds, forecast next quarter's sales using predictive analytics, and even execute algorithmic trades on the stock market way faster than any human could even comprehend. Now, to get all those different departments operating on the exact same intelligent page, businesses have to undertake a sequential journey to implement an enterprise resource planning, or ERP system. This unifies finance, HR, and sales all into one shared database. It's a massive 7-step undertaking: planning, selection, design, data migration, testing, training, and finally go live. And hey, if you have ever lived through an ERP data migration, you know for sure it requires relentless testing and a truly incredible amount of coffee. But once it's deployed, the unified efficiency is just unparalleled. Finally, we've reached our last macro block, Section 5, Cyber Law and E-Governance. The reality is that the digital world mirrors the physical world. It definitely has its fair share of bad actors. Cybercrime encompasses illegal activities carried out using computers or the internet, things like identity theft, hacking, or spreading malware. Because these digital crimes cause very real-world damage, governments had to step in. They established strict legal frameworks, like India's Landmark Information Technology Act of 2000, just to set clear, enforceable boundaries. And these frameworks, they give real teeth to digital enforcement. The real-world consequences outlined in the IT Act are intense. Section 65 targets tampering with source code with up to 3 years in jail. Section 66C hits identity theft with 3 years in jail. Section 66E addresses privacy violations with up to 3 years. And Section 67 penalizes publishing obscene material with up to 5 years behind bars. The law clearly treats these digital crimes with incredible seriousness. But cyber law doesn't just punish, it also enables us. The IT Act actually grants legal recognition to digital records through e-governance and digital signatures. By using cryptographic verification with public and private keys, a digital signature proves a document's authenticity mathematically. This is huge because it means you can legally file your taxes online or sign binding contracts right from your laptop, with the exact same legal weight as a traditional pen and paper signature. Well, we've just taken an incredible journey together. We started at the micro level with hardware and system software, connected it globally, pushed it into the cloud, empowered it with artificial intelligence, and wrapped the whole thing in a secure legal framework. You now understand the architecture of our digital universe. So here's my question for you. As AI accelerates and these boundaries keep shifting, are you just going to be a user of this system or an architect of what comes next? Something to think about. Thanks for exploring with us, and we'll catch you next time.